Hey guys, so we're going to continue with some more of the exponent properties today. So the first one we have is the power of a quotient. So now what if you have a fraction that is all being raised to a power? So we're going to go through some examples here. The first one, if you take a look at that, this 2 is being raised, this whole fraction actually is being raised to the second power. So what we're going to do is we're going to raise the numerator to that power and the denominator to that power. Then we can simplify 2 squared, which is 4, and we can simplify 3 squared, which would be 9. 4 over 9 cannot be further reduced, therefore that is our answer. Okay, so taking a look at this second one, it's a similar concept here. We have 2x in the numerator and y in the denominator, and they're both being raised to the third power. So the 2 and the x are two separate things. So we're going to raise both of those to the third power. So first we're going to raise 2 to the third power and x to the third power. And then in the denominator here, we're going to raise the y to the third power. So now if we try and simplify that, 2 to the third power is 8, x to the third, y to the third. We're done here. We can't apply the quotient rule because x and y are not the same base. So therefore, we are done. Okay, taking a look at this next one, again, it's pretty similar. We have two separate parts in the numerator here. We have 3 and we have x squared. So we're going to have to raise both of those individually to the third power. 3 to the third power and x squared to the third power. You might notice here, this is power rule, which you learned yesterday. So the shortcut is we multiply 2 times 3, which is 6. So we get x to the 6th power. And then in the denominator here, we have y to the third power, and that's being raised to the third. So that's another power rule. So we're going to multiply 3 times 3, which is 9. Now simplifying 3 to the third power, 3 times 3 times 3 is 27, x to the 6th over y to the 9th. That's completely simplified because x and y are not the same base. Okay, so now we're going to move on to our next rule of the day, and we're going to talk negative exponents and the zero exponent. So the first example we're going to look at is 2 to the negative third power. So the first thing you may remember your teacher telling you is that you cannot have negative exponents. What we do is we rewrite them as positive exponents. The rule I like to follow is if it's a negative exponent, cross the line and change the sign. So first of all, if we cross the line, we need a fraction here. So if we cross the line and change the sign, we need something in the numerator that is 1. So 2 to the negative third power is the same thing as 1 over 2 to the positive third power. 2 to the third means 2 times 2 times 2. So that is 8. So we have 1 over 8. In this second example here, now we have the negative exponent in the denominator. So if you look at the properties above, in order to make this a positive exponent, we have to cross the line and change the sign. So now we're taking it from the denominator and putting it in the numerator, and it becomes a positive exponent. So the answer to this one is just x to the 4th power. And then my last one over here, I have a couple different things going on. The first thing that I want to look at is I have d to the 0 power. You may remember that anything to the 0 power equals 1. And if we multiply all of this times 1, that's just going to be this. So realistically, it's almost like this kind of goes away because it equals 1. So just remember, anything to the 0 power equals 1. So now I'm going to look at the rest of the stuff we have there. First of all, we have a lot of negative exponents. We have a to the negative 2nd and c to the negative 4th. So first of all, I need to cross the line and change the sign. So I'm going to bring a to the negative second to the denominator and become positive. And then I have c to the negative fourth power, so I'm going to bring that to the numerator and make that positive. The b to the third just stays in the numerator. Since it's not a negative exponent, I don't have to worry about it. And you'll notice none of the variables are the same base here, so therefore we can just leave that, and that is completely simplified. If you did have coefficients, you would have to do exactly what you did yesterday, and you'd have to actually divide them. Okay, so moving on to the last section for today, we're going to work on converting radicals to exponentials and exponentials to radicals. So this first one is what we call a radical. We have the sixth root here, and we're going to try and write it without that sixth root. It's actually pretty easy. All you do is the index, that's what this is called, of the radical, becomes the denominator of the exponent, and the 5 stays. So what we have is, what's underneath the radical is 10b. We write that in parentheses. The 5 stays outside, and 6 now becomes the denominator in our exponent. And now we just eliminated the radical and changed it just to an exponential, and that is our answer. And I don't know why I'm highlighting everything in purple, just like purple today. Okay, so taking a look at number 2 here, we again have a radical, and it's telling us to convert it to exponential form. So I know the index of the radical must go to the denominator of the exponent, and everything else stays the same. So whatever is underneath the radical goes in parentheses, the 2 stays outside, and the 3 becomes the denominator of the exponent. And then just one more example of this situation. What if we have something like number 3 here? I don't see an index here. So does that just mean it's 0? Actually, it doesn't. If there is no number in the index, it's assumed that it is a 2, because that means it's a square root. So we can write that 2 in there. And then if I try and rewrite this as an exponential, I'm going to have p, the 3 stays the same, and the 2 goes to the denominator of the exponent. And that is my answer. And then last section here, now we're going to go the other way around. Now we're going to have an exponential, and we're going to change it to a radical. So I have this exponential expression here, and now I want to rewrite it as a radical. So the first thing we remember is this denominator right here is the index of the radical. Whoops. We know that. The 4x is underneath that radical. And now what's the exponent that stays? It's the numerator that stays on the outside. And now we have a radical expression. So realistically, all I did was basically take that denominator and move it to the index of the radical. Now this one is a little bit different here. If you compare number 2 to number 1, in number 2, we had the 4x all in parentheses. Here, the only thing that is being raised to the 2/3 power is the x, whereas in number 1, all of the 4x was being raised to the 2/3 power. So now I'm looking at just the part I highlighted in yellow here. That's the only thing that I'm going to change here. The 4 is just going to stay out front. That's the coefficient. The 3, again, becomes the index of the radical, and the x stays underneath, and we have the 2 still as the exponent. But you'll notice that the 4 is now out front, and the reason that is because it's not being raised to the 2/3 power. So you can kind of see the difference between number 1 and number 2. In number 1, the 4x is underneath the radical because it was all being raised to the 2/3 power. And number 2, it's out front because it was not being raised to the 2/3 power. And then our last example of the day, a to the 5/3, pretty easy. The 3 goes to the index of the radical. The a stays underneath. The 5 is our exponent outside. And now we have a radical expression. Okay, so overall, just 3 different things today. Converting exponentials to radicals and radicals to exponentials is one. The other was the negative exponents and zero exponent. And the third thing we reviewed was the power of a quotient. So hopefully this video will help you to complete the assignment along with this.